Hello, you welcome once again to my channel. So today we want to solve this utility function. So supposing you are given a function like this, u is a function of x1, x2, and it is the objective function which is subject to y equal to p1 x1 plus p2 x2, where p1 equal to 10, p2 equal to 16, and y, which is income, equal to 300. So you have to find the equilibrium level at which the consumer maximizes his utility. So this is what you do. First, you restate the functions or the equations properly. Then you can have you said okay, we are to maximize the utility, which is the function x1, x2, x2, that is your equation 1, and this utility is subject to this budget constraint p1 x1 plus p2 x2, which is your question number 2. This equation number 2 can be rewritten as follows: y equal to p no y minus p1 x1 minus p2 x2 equal to 0 as equation 3. Then you can impute the values. You can impute the values that you got for p1, p2, and y. So y is 300 minus p1 is 10, that makes it 10x1, minus p2 is 16, that is 16x2 equal to 0. This is now your equation 4. So what happened here now is that you introduce what you call the Lagrangian multiplier. Introduce the Lagrangian multiplier. Now, what happens here is you bring the first equation like this. This is your you have x1, x2 plus the lambda. Then you bring in equation the equation 4 into it. Then close brackets. You can call this equation 5. You can rewrite it, just remove the f to look like this. And you introduce the lambda. 300 minus 10 x1 minus 16 x2 In fact, let this be your equation 5. So you cancel the other equation. Now, if this is now your equation 5, the next thing you are expected to do is to take first order condition. You take the first order condition with respect to x1, x2, and lambda. So first order condition, the FOC with respect to x1. You look at this function, you take first order condition, it's a partial derivative. You take the derivative with respect to x1, which will be dl, that is this function, dl with respect to x1 will give you, when you differentiate this function here with respect to x1, you are left with x2. And when you differentiate this other function that have lambda with respect to, you differentiate the whole function with respect to x1. Now every other thing there assumes 0, and you are left with 10 minus 10. So it comes with minus 10 lambda, because lambda will still come. Now this, you equate it to 0. Is your equation 6. You will do the same thing, FOC with respect to x2. So this, you check the equation. Let's so that we don't lose sight of the equation. So you have the L, the x2, and you do the same thing again. With respect to x2, you are left with x1. Then with respect to x2 in this 16, so you are left with minus 16 lambda. The lambda will be there, equals to 0. Now this is your equation 7. So now you can do the same thing now with respect to, that is FOC with respect to lambda. Now with respect to lambda, you are differentiating lambda, you leave every other thing. So what you have, x1, x2 here will go, and you'll be left with that's the L, the lambda. You'll be left with 300 minus 10x1 minus 16x2 equal to 0. This is your equation 8. So far so good. What you are trying to do is to find a way to eliminate lambda and calculate the value of x1 and x2. So you are going to rearrange your equation 6 and 7. So your equation 6 and 7 becomes like this. From equation 6 and 7, we have okay, x2, instead of minus 10 lambda, you move 10 lambda to the other side of the equation, becoming plus. So you have this, and this x2, you also do the same thing. You move 16 lambda to the other side of the equation. You have plus now 16 lambda. So here you divide equation 6 by equation 7. So what you have now is x2 equal to 10 lambda all over x1. Okay, sorry, here is your x1. Here is your x1. So let's take that again. From equation 6 and 7, we have x2 equal to 10 lambda and x1 equal to 16 lambda. So you divide equation 6 by equation 7 and you have this 16 lambda. So invariably this is what you have. All over 16 lambda. So you cancel lambda, cancel lambda. This is, so you are left with x2 all over x1 equal to 10 all over 16, and this will automatically give you x2 all over x1 equal to, when 2 goes into 10 you have 5, 2 goes into 16 you have 8. So the next thing is to cross multiply this to give you 8x2 equal to 5x1. Now from this equation you can decide to, from this equation you can decide to make x the subject of the formula. You can decide to make x1 the subject of the formula. You can decide to make x2 the subject of the formula. So it all depends on which one you want to make as the subject of the formula. They are all going to give you the same result at the end of the day. So let's make x1 the subject of the formula, which of course now you're going to divide both sides by 5. So you have x1 equal to 8x2 all over 5. Now you can call this, what is our last equation? Okay, what is our last equation? That is equation 8. Now you can call this equation 8. So you substitute equation 8 into equation, which of the equation? The one with the lambda, when we differentiate the equation 8, sorry. So that is equation 9 then. Let's clean it. That is equation 9. So you divide equation 9 by, you substitute equation 9 into equation 8. So you have 300 minus, now 10x1. So instead of x1 you have 8x2 all over 5 minus 16x2 equal to 0. So here you can just be careful. You can decide to use the long method of LCM, where after clearing this up you have 300 like this. 10 times 10 times 8, you have 80x2 all over 5. You have 16x2 equal to 0. So what you have here, you can of course take the LCM to be 5, and you multiply through. So what you do is 5 here, here is 1. 5 multiplied by 300, you have 1500 minus 80x2 minus, here is also 1. 5 multiplied by 16, you have 5 multiplied by 16, you have 80x2 equal to 0. Now here everything is all over 5. But when you cross multiply at the end of the day, what you have now is this minus 80x2 minus 80x2 equal to 0. So you sort of like arrange to have, this is minus 80x2 minus 80x2 is equal to minus 160x2 equals to 0. So you move this 160 to the other side, you have 160x2. Now to have the value of x2 is to divide both sides by 160. So you have x2 equal to 1500 divided by 160. So therefore x2 is giving us, this is 160. x2 is giving us 9.375. Now that you have 9.375 as your value for x2, you can simply go and substitute the value of x2 into equation 9. You understand? So you substitute the value of what? x2 into equation 9, where you have x1 equal to 8x2 all over 5. So what do you have? x1 equal to 8 into x2 is 9.375 all over 5. So you end up having x1 equal to, when you multiply, you have 75 all over 5. And when you divide that by 5, you end up having x1 equal to 15. So finally, x1 equal 15 and x2 equal 9.375. These are the possible combination that will maximize the utility of the consumer given the budget constraint. So we can have more examples, but let's go with this for now. Thank you very much, and see you next time.